All right, any questions before we dive into the day's activities? Yeah. Project 4, I will probably kick off formally after spring break. Project 3 is dead on arrival. I will probably, I'm thinking there will be some form of Project 3 that will come after Project 4. And after spring break, obviously. So I believe, let me actually, I don't remember what we do on Friday. Yeah, so the Project 4 will be kicking off after spring break. Now, so it's worth talking about now. What this says is, this is going to be hard for me to pull this off because people, including myself, get totally into spring break and totally not into school. But here I have week 9 Sunday. This would be just before you come back. There are handouts for Project 4 that I'd like you to read. So I guess I wouldn't worry about it. I'll send out a reminder to do that. Which, by the way, I actually found this out. I keep forgetting about it, but found it out several semesters ago that, let me ask it as a rhetorical question, meaning I don't require an answer. How many of you are actually getting an email? How many of you actually know that you have email? How many check your email? I know that this is the new generation, and email's like, ooh, the grandparents thing. But I post these after every class, and whenever I post one of these, this Blackboard system sends out an email. And so if you're not receiving those emails, then figure out what's going on with your email, because the address that this is going to is where all university-related emails are going, including advising that you need to be doing upcoming, particularly if you're a computer science major. So I just throw that out there. If you're not getting emails from this class, then debug it and figure it out, because you're going to run into huge problems down the road when you find you're not getting emails and you're not able to graduate because you didn't get the email that said you have to do this, that, and the other thing before you can graduate, and blah, blah, blah. Just throwing that out there. It'll save you a lot of grief if you're not getting my emails to debug that now, rather than your last semester as a senior and realizing that you've been missing all sorts of fun things. All right. Any other questions?
What are we going to do for the next lab?
Say that again?
What are we going to do for the next lab?
What are we going to do for the next lab? Oh, there's only one lab this week. But there are 2 assignments this week. So there's an assignment today and there's an assignment on Friday. So the lack of a lab is made up by the fact that there are actually 2 programming intensive assignments that are happening today and Friday. So probably the assignment you get today you should be working on in lab, assuming you've done the lab already. Yeah? All right. So when we left off last time, we had begun this idea of how to approach a problem from an object-oriented perspective, and we looked at that somewhat small and contrived, but it took baby steps towards analyzing a problem from an object-oriented perspective. And there are a couple things that I had identified as being key to this idea of approaching a problem from an object-oriented perspective: abstraction and encapsulation. Abstraction was describing something in terms of how it's used, and we had this idea of a web counter, and we identified these 4 things as the way we use the web counter. And the second part was encapsulation, the bundling together in the same capsule data So I discovered yesterday, remember I was trying to debug my camera thing while I was screen recording. I got that debugged and found out I was actually able to look at my phone's screen while I'm doing a screen recording, which is actually better than my previous solution, which was the camera on my computer. I think what this lets me do is do that wirelessly, whereas I've got a wire hooked up, so it isn't an issue. But I'm a glutton for punishment, so I like repeatedly hitting that install button and having it tell me that I'm a failure. All right. Okay. It's like I'm back in grade school again. All right. So the encapsulation is we have these behaviors, but we also have this idea that these behaviors are operating on data. And it's the bundling together, and so the term encapsulation is borrowing from the word capsule. Bundling together in the same capsule these behaviors we've identified with the data that those behaviors operate on. And we saw in this example that data was some sort of number, an integer representing the number of hits. There are actually two pieces to the encapsulation. That'll be piece one. The second one is data is only so if I have this web counter thing bundled into the same capsule, there's no way for me to touch that integer representing the number of hits. I can only access it, if you will. I can only interact with that data through these four behaviors. In this example, through these four behaviors that have been provided. I'll elaborate on that more. Today we're going to actually go from this form in a little bit to actually what that looks like in code, and I'll be able to elaborate on to in a little bit more detail when we get to a technical level. But despite the simplicity of all this, I really think it's valuable to drive this home with a little bit of role playing. And in the following project, the role playing gets quite a bit more involved, so this makes a nice dry run, if for no other reason. So I had mentioned last time, and that's why I was originally firing up the camera, that I wanted to have a couple volunteers come up and actually be web counters that I would interact with. I have two volunteers who are willing to come up. Let me see, it's 9:14. That gives me, 36 minutes to wait for two volunteers? Yeah, come on up. You don't have to raise your hand, just walk up. Hey, all right. I usually get the applause after the performance, so you all are better than most. All right, one more. Come on, whoever comes up's really going to get the applause. I can feel it. I can feel it, and you're going to want that applause. All right. No installation failure dialogue for you. Come on up. All right, there we go. Okay. Now this is where it gets real here. All right, you can kind of feel the excitement. Okay, wait a minute, watch this. As I said, I did my homework and played with this. And, all right. Here it comes. Oh, where is my phone? Why is it not showing my phone? There we go. We could see what's going on. Tehama. I can't believe it's not doing this. So I may just have to turn my computer around. I was so excited to try the phone though. Let's try this just as a wild card final try here. No, it doesn't look like it wants to play. Let me drop down the menu one more time in case we get a magic refresh. There it is. Thank you. Thank you. I appreciate that. Okay. Oh, why isn't it doing it? Your applause was a little premature. Oh, this is such a drag. It was working. No, no. I'm not going to fall for that again. Huh? Yeah, I mean, no, when I did it last time, it actually showed my screen, and then after I went to the camera, right, it literally just showed whatever I was seeing on my phone screen, whether it was the camera or the icons. All right, there we go. Ooh, my failure is complete. Okay, I think I'm a glutton for punishment. I am going to try it just one more time. You know, I'm actually curious what that is. Okay. It'd be so great to see some professor in their office working away. I mean, I'd actually dedicate a whole class to that's just watching that. All right, I'm gonna have to abandon the phone. Clearly, the bugs are still being worked out there at the Apple headquarters in Cupertino. So once this thing recovers, now it tells me. All right, so I am going to, if I could ask you all to squeeze in frame here, and we don't need that to be quite so large. And what I'll do is I'll do that so we can look at the notes at the same time. And then if I pull my mouse off that, the little recording doohickey should go away, I think. Go ahead. I guess I'll record. There we go. Okay. I have for each of you that. And what these pieces of paper here on the file folders represent is just their internal data. So in the example here, this would be the integer representing the number of hits. Now you don't need to put anything there yet. Can I go ahead and get your first names?
Matt.
Matt? Jasmine? All right, Matt and Jasmine. So the first thing I'm going to do is I'm going to say Jasmine reset, and what is Jasmine going to do when I say to reset? All right, so set the counter, meaning your internal data to 0. So make it big enough so we can all see it. Don't take the whole page because you're going to have to make several corrections. Just put a 0 on there. And then you can just kind of hold it up. And Matt reset. Okay. Now, how about Matt hit, Matt hit? What's Matt going to do? All right, so cross it out and write 1. And then I did it a second time, so cross out the 1 and do 2. All right. Jasmine set 32. What's going to happen? I mean, this is so simple and straightforward and intuitive, right? No big deal. I assume we're not freaking out here. I'll throw a curveball at you, though. Matt set -99. What do you think? Does that sit with you the wrong way? Why does it sit with you the wrong way? Exactly. So in the context, so this isn't just an integer that can have any negative or positive value to it. It has a context. It's representing the number of people who visited a page. And so having a negative number is nonsensical. So what would be an appropriate behavior, do you think, if I ask Jasmine to set negative 99? If I give a number less than 0, how about that Jasmine just checks that, and if I did give a number less than 0, just set it to 0. That seem plausible? All right, so Jasmine set negative 99. And you can cross out the 32 and just put 0 here. All right, so this brings up an interesting point about approaching a problem from an object-oriented perspective, is that I had conceded that this was a bit contrived and a bit simple, but what the reality is when you're dealing with something complex like the scheduling system for the university, right? And I said how you'd be interacting with customers and they'd have conflicting stories. This is a trivial example of where something unexpected comes up. We think we got this thing nailed, right? Yesterday we typed this out, and I don't think there was any confusion as to what was expected, and yet we came up with a scenario that we hadn't considered before. And in that case, what would happen actually on the ground doing this for real is you would have to say, we go up to the customer and say, we've been working through this, and we came up with some situations where it doesn't make any sense. What should we do in these situations? And you have a conversation with the customer, and maybe in this case, we go talk to the developer dealing with the web page, and they say, well, just if you get a negative number, make it 0, right? So this is an example of where software engineering is so interactive, because we came up with something in a very trivial example. You spend all day just ferreting out these kinds of problems of misunderstandings and not being clears and things like that you have to work out with the customer. All right? Okay. What have we not done yet? Let me see. Hit. How about Matt get? Yeah, okay, so we have a little bit, if we're trying to translate this to code, we're not sure what that looks like, but there's some sense that Matt's going to give me that number that you currently have. Now, you don't want to actually give it to me, but I think the suggestion, you can just bark it out loud to me.
2.
There you go, okay. What about me doing this? Hold it. Hey, what have I violated there?
My personal space.
I have absolutely violated it. And I'm sure there's some department you can go to talk about me aiding your 2, so to speak. You just go in there and just say, he aided my 2. I want action. In the context of the notes up here, what have I violated? I haven't used one of the commands. Yes, that's true. And what am I violating by not using one of the commands? Encapsulation. I violated encapsulation, right? So in this idea of an object-oriented design, I am not allowed. I am a consumer of these types. I am using the web counter. So there are a couple different roles here if we think in terms of software development. There is the developer who wrote the code that comprises these web counters, and then there's the consumer or the user of these web counters. Now, you all have actually been consumers of a lot of object-oriented, the term would be classes. There's the web counter class. You've all been consumers of classes in this course, and the best example is the string. The string is not a built-in type. Int, float, char, those are bool. Those are all built-in types into the language. String is not built in. Some software engineer sat down and actually wrote that class, and they went through a process similar to this of coming up with the behaviors that comprise a string, and it has private data. It has a few pieces of private data, actually, and you're not allowed to access those directly. But here's the interesting thing. You don't care what that data is, right? You just want to use the thing, and how it deals with its own internal stuff is its own business. And that's part of the joy and the benefit of this idea of an object-oriented design, is that you don't have to concern yourself with the details if you're a consumer. Okay, I think that's all I need, so I certainly appreciate it. Thank you very much. Let's hear it for me. No, 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 no. All right. So let's talk about that in terms of code. Now, I talked briefly about structures, and the scenario I gave is where you have a bunch of data that fits together. Struct, I don't even remember, what was the example? I don't remember what it was. It was something like student, and there's a string for the name, and an integer for the age, and a float for the GPA, something like that, okay? And this is a construct that goes back to the C language. It's alive and well in C++, but that's all it is data. This syntax that you see here is borrowed for when we're dealing with this object-oriented realization of these things, and I called it a class, and in fact there's a keyword called class. You can see the syntax highlighter making it green, showing that it's a built-in part of the language. It's a web counter. And I'm going to have curly braces. It ends in a semicolon. We know that I have an integer representing, let's call it like visitors, the number of visitors that have come to the web page. And then we had hit and reset and set and get. All right. These actually end up being functions, and if you recall, all functions have this syntax. The type of the return, the name of the function, and then needs to be input parameters. All right, and let me put all that. So we have the YYY, if you will. These are the names of the functions. I know that I'm going to have parentheses after all these. Let's talk about hit. What kind of thing is returned? When I said Jasmine hit, what did Jasmine give back to me? Huh? Well, that's one. It's certainly one possibility. What's another possibility? Right. So there's another possibility. I would say that it's actually void, because I said Jasmine hit, and then she just updated her internal data, but then didn't turn around and give me any information. So there's no response back to me. So I would say void is the way we want to go with that. What about input parameters? What did I provide to Matt when I said hit? Did I say, Matt hit, and by the way, here's a picture of my mother? Did I give anything to Matt when I said hit? No. So that would be left blank, or as we saw from the exam, either void or blank are both valid, meaning no input is provided. So I'll leave void there, just because I haven't been using it much. But I'll concede you see that most of the time, just leaving it empty. Reset. When I kicked things off, I said reset. Did they give me anything back? No. and I didn't provide any information. How about set? Did I provide any information? Yep. How about, was I given anything back? No. And then finally, this is void. I didn't provide him any information, but in that case, Matt did call out, I think the example in that case was 2, right? Responded with my request. I said get, and a 2 came back to me. So there was an integer that came back to me in that case. So this is valid syntax here. It's a little bit incomplete. First of all, the encapsulation, or the part about only being the behaviors are only accessible, there's no, the compiler sees these all as the same. It doesn't go, oh, this is data, so it must be private, and oh, these are functions, or excuse me, these are data, so I can't access them. These are functions, these are precisely what I access. Actually, the programmer has full control over that, so you do have to specify it. By custom, it's not any syntactic requirement, but by custom, things that consumers, users of a web counter, would use come first, and you precede that list with the word public and a colon. Then I indent it for visibility, and then this would be private. And this is data that consumers don't have access to. This is what I would call a class declaration. And this is typically found in a header file, such as webcounter.h. So if you recall breaking things into separate files, the things we put into header files are, sorry, I'm used to looking at the time up there. Things have changed on that wall. The purpose of the header file is that it tells the compiler what things are should we decide to use them. So it doesn't take up space per se. It's literally just information for the compiler. So should I decide to use a web counter down the road or create a web counter down the road, this is giving me, giving the compiler the information so it can help me use it correctly. What's missing from this are what each of these do. Now, these examples are so simple that you can predict what they do, but the compiler can't. And to really drive that point home, what if I change these functions? Right now, if I asked you what do these functions do and you'd never seen this class before, you wouldn't have the slightest idea. So you can't, the compiler can't infer from the names is basically what I'm saying. So we need to provide some sort of definition as to what these functions do. Now I'm going to pause and I'm going to go to a slightly different topic, totally out of the blue, and I'm only going to go there for a minute, and we'll come back to it because it'll be relevant in a few minutes. I'm going to create a function called add more. And what this is going to do is it's going to take an integer x, and I'm going to return x. But what I'm going to do is I'm going to add if I was to write a program and I threw this function in, the function will not compile. Can anyone tell me why that function will not compile? Say that. Here? Oh, okay, so you're kind of focusing in the right area. What's the issue with 3 more? Let me actually change it. There, now, same question, huh? Doesn't know what it is, right? The compiler doesn't have, and I just called it 3 more so it's easier on our eyes. The compiler has never ever seen It hasn't seen 3 more before. It doesn't know what it is. And this gets into that one video tips lecture that you all watched, I hope, on scope and visibility. Right? It's possible this variable was created in some other function or in main, but this function can't see it. This function has no idea what 3 more is. It will not compile. Hold that thought. Just keep that in the back of your head as we move forward here. All right. I need to write these functions, and it starts out, I don't want to write them all because the assignment is actually for you to write some of them, but let me focus on get. So I'm going to copy and I'm going to paste this, and this stuff, and it's going to have curly braces. This stuff is what I would call the class definition, the definition of the classes, and I would call these member functions. Sometimes you hear them called methods. This is what each of the functions do. So what does this function do? It's somewhere between 50 and 75 lines. I kid, it's 1 line. Give me 1 line. Return, yes. What are you returning? Visitors, yes? Everyone buy that? When I turned either Matt or Jasmine and I said get, I was given whatever their number was. And so that file folder had their visitors variable is what it had on it. But let's come back here. What's the problem with looking at that? What's the problem with the function on lines 34 through 37? Visitors is private. That's, I guess, I would be more general, and I would just say the compiler doesn't have the slightest idea what visitors is. It doesn't matter whether I call it visitors or 3 more or FDSA. The compiler doesn't know what that is in the context of this function. So what I have to do is I actually have to annotate this function and say that this function is part of the web counter class. And that's the syntax. You name the class, and then you do 2 colons, and then the name of the function. Now, let me say right now that a lot of people starting out will put this at the very beginning, and it'll be web counter : : and then the type of thing that the function returns, whether it's int or void. That isn't where it belongs. It belongs up against the name of the function, and it's saying that that function is part of one of the behaviors of, that's what I want, methods / behaviors. One of the behaviors of the web counter class. Now it will compile fine because on line 29 we said every web counter we ever create, and I created 2 up here, Jasmine and Matt, will have a visitors variable. So now when we say this function is part of the web counter class, then it goes, oh, okay, visitors, yeah, every web counter has visitors, so I'm good with that, and that will compile just fine. All right. Now, for whatever reason, this is so easy to understand, and when I'm up here interacting, it's a big nothing. It makes so much sense. But people get to this code, and they go, well, where is visitors? How in the hell can this thing work with visitors? I better pass in a variable called visitors. And that would be like me saying, Matt, get, here's the 32, and then Matt goes, here's the 32 you gave me. You see how silly that is up here? But for whatever reason, when people get looking at code, they think they need to do that. They can't get their head wrapped around that this web counter has the data. And you just work with the data inside these functions. All right. So, let me see, is there anything more? So what does it look like to actually write code to do this? So I said, can I have 2 volunteers, please? And Matt came up. And Jasmine came up. And then I said, Matt, reset. Jasmine, whoops, yeah, that's right. Reset. And then I said, Jasmine, I don't remember who I was talking to. Hit. think that was Matt. And then I said Jasmine, or no, I don't remember who I was talking to. Doesn't matter. Doesn't matter. Just move forward, Todd. I'm getting hung up on. Let's go back to the video. All right, so this one bears a little bit more information. What happens when I say get? It returns a number, right? So on line 51, a number's coming back to me. So this is perfectly legal to write it like this, but it's like me saying 5 plus 4. Well, what the hell are you going to do with it, right? It's an incomplete thought. So it depends on the application. I could say int a equals, or I could say cout. I could just directly spit it out to the screen. Right? The whole point is that expression, jasmine.get, is giving me a number, and I have to do something with it. Assign it to a variable, print it out, do some arithmetic with it, whatever the application requires. All right. So let's talk about the assignment then. Oh, actually, let me talk about the last bit of encapsulation. I think all the code here will work. No, normally it said this is normally in the this would be webcounter.cpp, typically found in source file. So that's where all these functions are. There should be 4 of them. And then the first thing you would need is pound include webcounter.h to get that declaration copied in there before you start defining the functions. All right. This, I believe, is... That won't compile. We've already established that. I'll leave it here. This isn't being used. It's not doing any harm, so I'll leave it in there. I think everything here is correct. Now, the application's incomplete because there are 3 member functions I haven't written. I haven't written set, reset, or hit. But it will compile the machine-readable code. I just can't create a running application because I still have 3 functions missing that I would need to write and compile and link in. So let me try compiling it. And again, if you watched the 4 steps to the compiling process, you would know that I could add the -c option. Whoops. So I need to pound include string, and I don't have the IOStream stuff. Pound include IOStream. Pound include string. Probably don't need that one. It comes with IOStream using. Take everything in the standard library and just be able to use it without worry. Try it again. And with any luck, I get my prompt back. Okay, so that it did create machine-readable code, but I'm missing functions, so I wouldn't be able to create an application. It would fail if I tried to do that. The reason I wanted to illustrate this is to talk about the second part of encapsulation, which I don't have in the notes. Where did I have that? Sorry. This stupid utility I installed. ls. All right, this second one. Data is only accessible to the behaviors. Those outside, so data is only accessible to the behaviors. Right, meaning that here the behavior is able to access that private data, meaning that the visitors was not inaccessible, obviously, to Jasmine or Matt. They're able to manipulate their own data. That's what's being illustrated here. That's what this first sentence is saying. Those outside of the capsule, meaning me, using the web counter, I am not able to access the data directly. And let me show you what happens if I try to. So if I say mat.visitors equals 8, then I try compiling it, and it won't even compile. and it tells you that it's a private data member and I'm not allowed to access it. So that's how data encapsulation is enforced, is you are unable to compile your program if you try to violate encapsulation. Okay? All right. I'm quickly running out of time, so hang in there while I very quickly go over the assignment. So the assignment is assignment 13. There's a tarball that you can download right here. Let me download it. And it gives you a command for extracting it. Let me copy that. I'm going to move from my downloads. Oops, I'm going to move it to my current directory. There it is. I'm going to extract it. Compressed, extract, be verbose, so we see. Let me clear the screen, do it up top. It creates an assignment 13 directory. Inside there, it creates a bunch of files. Let me go into A13. There's a make file. It probably won't build because I don't have enough information yet. Let me look at webcounter.h. There's nothing there. You have to write the class declaration. That should be pretty easy, I would hope, because, whoops. I provided the class declaration. That's all this stuff here. If you recall from the lab where you have to divide up files, you have to put header guards, the pound if ndef, webcounter_h, define webcounter_h, and pound ndif. You can go look that up. That's just 3 lines to either side of this. But this is it. Basically lines 25 through 33 go in this file in webcounter.h. Webcounter.cpp. There, that includes been provided for you. And you have to write the 4 functions. I did provide the one for you. Then there's stuff down here that you don't need to worry about yet. In fact, let me see, what does this say? So I can actually comment this out while I write the 4 functions. So I write the 4 functions here, and then I look at the test program, and I create a web counter, reset, and then you can see here's get here. There's some gets here. It's telling you what the values should be. Here it's setting it different values, a couple hits. And this should let you test it. So you should be able to, again, I did have to comment the lines out here, so go ahead and comment those out. Then write the 4 functions here. I did provide one of them. You should be able to type make and get a fully running application, and when you run it, the output should tell you whether it's correct. You'll note it should be 0, and it is. If it shows something other than 0, you got a bug. You get that totally working. There are 2 more functions you have to add, which is load and save. And that means open up a file, open up counterdata.txt and write out the number of visitors. And this one means open up, in this case, counterdata.txt and read in the number of visitors. And you do those last after you get the other 4 working. So that's the assignment you have to do. Assuming you're done with the lab, this is what you want to be working on now, because I got another one with coding coming at you on Friday, and you don't want to wait till the last minute to get it all done. Okay? All right.